Today, what we're working on, I've got a customer, he's a pretty badass dude. He is completely refitting a 28-foot Pursuit. This boat had twin inboards. He's converted it to twin 300 outboards. So we actually built him a pod, as well as a couple other custom things, and we're doing these offshore fuel tanks for him. So this is the first of a 2-tank system. These 2 tanks are gonna go forward of his main tanks. So these 2 tanks will total 280 liters of fuel, which I think ends up being about close to 500 pounds of fuel that's now gonna be in the middle of the boat, getting absolutely thrashed while this guy goes way offshore to fish for tuna. So I wanted these things to be super heavy duty. That's why I've got the baffle system in here. Everything is 3/8 plate, 50-52 aluminum. I'm gonna be isolating these tanks with Delrin isolators. So I'm gonna talk a little bit later in the video what Delrin is, why we're using them to isolate the tanks, a little bit about galvanic corrosion, and how those stainless bolts can corrode aluminum, and that's the galvanic corrosion process. So we'll talk a little bit about that later in the video. For now, let's start welding some tanks. Okay guys, I've talked about this before, but cleaning your parts before you weld them is pretty important. A lot of aluminum comes with a this kind of plastic film, and obviously you're going to want to pull all that off. Now your part isn't clean just because you pulled the film off. There's a little residue of the glue left over. Acetone's your friend when it comes to this. Now you can use a lint-free cloth. That's probably better than using paper towel. Paper towel leaves little fibers behind, but I'm going to show you how I get rid of those. You can see all those little fibers coming off. That's all going to contaminate your weld. I made a big deal about this in my other videos about the brushing. The acetone's probably more important to get all the oil and the contaminants out. A little compressed air doesn't hurt either. The advantage to the router is when we get these router cut, it doesn't leave any sand or silica like you get with a water jet. There's no dross like you get with a laser or plasma, but you do get this small, fine little burr. And what I've noticed is when you're trying to fit these parts together, those little burrs can interfere with your fitment. So you can either file them off, works pretty good too, or I just use a little deburring tool, and that makes really quick work of it. So one of the downsides to the router is a round tool bit. Sometimes you're going to end up with these little radiuses in the corners. You wouldn't get that with the laser or the plasma, so we just got to take the time after and just file that stuff out. Not a big deal. Just get rid of that round edge. For everybody that thought they were never going to use a file again, still using one 25 years later. Another thing you can do, guys, is it's always a good idea just to clean your welding rods with a little bit of acetone. You don't think they're going to be that dirty, but I'll show you in a sec here. So that's what comes off of your nice clean welding rods. So there you go. Okay guys, so for these tanks, we're using a baffle system. So generally you're going to have baffles on larger tanks just to prevent the fuel from sloshing around. Fuel actually weighs quite a bit. These tanks, like I said, are totaling 280 liters of fuel, and because it's an offshore boat, I wanted to have some heavy duty baffles in there to really strengthen up the tanks. So this is our baffle system. We're going to start by tacking these together, and this is going to help us when we assemble the rest of the tank. satisfying part. Okay guys, this is going to be the bottom of the tank. I try to form as many bends as I can, so every bend that you're able to form is a bend that there's a joint that you don't have to weld. So that's going to reduce your weld time, that's going to reduce the cost, it's going to add strength, and it is going to reduce distortion. So these are all pretty big things. So what we're going to do now is these are the baffles that we just tacked up. Throw those inside. Oh yeah. Okay, let's tack this bad boy. This is my my mega clamp. Just going to use this to bring the sides in here. Something you guys might want to invest in. I like to use the little thumb switch on my TIG torch. A lot of guys run the foot pedal, they've never done this. It takes a little bit of getting used to, but honestly, not having to deal with a foot pedal, once you get used to this, you'll almost find that it's better for, especially for aluminum boat stuff, where you're crawling over things. You can't always get your foot to a foot pedal. We got everything tacked up now. I'm pretty happy with that. Alignment, everything looks good. All the gaps look really good. This is the advantage to running CNC cut files. Everything should fit near perfect if you've done your design work correctly. And looks like we have. So we're gonna weld this out. Now another safety consideration worth thinking about, aluminum has been linked to Alzheimer's. So if I'm ever going to do a lot of aluminum welding, I always try to wear a respirator. I like these ones with the little snorkels that go behind your back. It just helps pull in fresh air. So I would definitely recommend take care of your lungs. Okay, we got all the baffles in. You don't have to go crazy on the welding inside on the baffles, just enough to hold them in place. Their role is to stop fuel from sloshing around, and they add a little bit of structural strength. But so it goes in, we're going to put these end pieces on. And the way I design these, and I kind of recommend this, is to have them not the same. Basically, you want to have a little bit of overlap here. I don't know if you can see that. That's kind of what you're looking for. So the plate sits nicely, but then you can fill in a nice little weld there. So that's what we're looking for. Again, that comes down to the design process. You have a good design, the CNC router should do the rest, and then when it comes time to weld, your life is easy. I'll explain what this is for. So guys, if you got a little bit of a gap, there's no real gap here, but what you can do is a little trick. What I just did there, put your weld in, it's called a hot tack. When it's still hot and molten, but solidified, you give it a little hit with a hammer, that's gonna suck up a little gap. So that's a nice little welder trick if you're dealing with spots where there's a little bit of a gap and you just wanna seal it up. I think everybody should make their tanks out of 3/16. Just makes this kind of stuff just so nice. So we are working on the port tank. So far everything's looking right. So when I designed designed these little slots. I designed them exactly 3/16, and what I found is they fit just a little bit too tight. So we're just going to file them out. Okay, so here are the fittings that we're going to be using. So these are all fittings that you can actually get at Adventure Marine. We're going to have these on the website along with a bunch of other stuff. Or you can make them yourself on a lathe. But if you don't have a lathe, they're pretty inexpensive and they're going to work real good. So we've got these different hole cutouts. We use the Moeller series fuel senders. These are the Reed style. You can get different styles, but this is really common in the marine industry. I've made up these little Moeller fuel sender plates. So they come tapped already with the Moeller hole pattern already in them. So all you got to do is take this, cut your hole, weld it on, and then your Moeller fuel sender is going to drop right in and it's going to line up with those holes. So that just saves you drilling and tapping. Especially in thin aluminum. This is 3/16, you could probably drill and tap that and it wouldn't be an issue. On the 1/8 aluminum, I mean, you really don't have a whole lot of threads there. So having this 1/4 inch plate is just gonna give you a little bit more security, a little bit more holding power with those threads. We have these. This is just a standard weld bung. This one's tapped in 3/8 national pipe thread. We also will be using a 1/4 inch NPT thread as well on this. And these particular ones, these are for the fuel pickup. So we'll actually weld in the fuel pickup line. I usually get these made just slightly undersized because I like to just, part of the deburring process, I might as well just use the die grinder and just get a real nice fit. So right now, doesn't quite fit. Just gonna throw a little die grind in there. And there we go. Also, if you're gonna cut your own holes, cut them undersized, die grind them 2 sides just so you get that real nice fit. That's what we're after. For installing the Moeller fuel sender, what I like to do is, if you've got the sender here, the thing about the Moeller 5-hole pattern is the spacing isn't actually even, so you have to actually think about the orientation of these things. So if you can at least put your sender in and think about where you want the wires to go. What I've done is I've just pre-marked my circle, drawn with the Sharpie here, so that when I put this thing in, at least get it relatively centered. I want my wires to run this way. And I'm just going to mark these holes and I'm going to through drill them. Go. So the Moeller screws are number 10, so we're just going to go a couple sizes larger than that. You know, if you do a 1/4 inch, something like that. Yeah, let's do a 1/4 inch. So now when we go to weld our center plate on, all those holes are drilled through and the center can just thread right into the plate. So the customer asked to add another fuel pickup, so we've got a total of 3 fuel pickups on these tanks. So each tank has a primary pickup, which is 3/8 NPT, and that's for each of the 300 horse Mercs. So each one gets its own fuel pickup. Then we're gonna add a 1/4 NPT pickup for the kicker motor. And that's what we're gonna do here. So that was an add-on that was done before, well, it was done after I finalized the design. So I'll just show you how I cut these. Figure out where you want it to go. In this case, I know I've got a baffle plate here, so I've got to avoid that. And I've got to have enough room to thread the fitting on. So looks like it's not gonna interfere with anything. That's a pretty good little place. Just gonna mark it out. Oh, look at that. Let that puppy cool off. We've got our tank tacked up now. This is your last chance to double check everything. Make sure everything's all good and that you got your field pickups the right length. That one's good. That one's good. Double check everything on our drawing here. So we got our molar fuel sender. It's gonna go here. We've got a breather vent that's gonna go up here. Fuel pickups, this is where the fuel fill is gonna go. So we'll do that a little bit later on, but anyway, that's the fuel fill. So everything's looking good. So this is it. We've got our tacks and all our spots. What I'm gonna do is I'm gonna close off all the corners. So close off all the corners first, so that when we're doing our finished welds, we're not welding off the end and melting everything. We've already got a weld that we're coming into. So that's our first step, close off the corners, then we're gonna weld everything up. Okay, so we got the tank all welded up. The last thing is to, well, not the last thing, but what we're gonna do next is we're gonna weld all the fittings on. So let's do it. Okay guys, so now we've got the tanks welded up. We've got our fittings welded in, minus our fuel fill. So that's gotta happen. And then on this particular tank, there's gonna be some mounting hardware that actually bolts the tank to the boat. And that's what the Delrin bushings are all about. So I'm gonna get into that right now. Tell you a little bit about Delrin, why we're using Delrin. I talked at the beginning of the video about Delrin isolators. So what we're gonna do, I'm gonna explain why we're using Delrin here. Here's all the little isolators that we're gonna be attaching to where the bolts are gonna go through. on these tanks. So a lot of you have probably heard about galvanic corrosion. There's a electrical process between aluminum and stainless steel. One becomes an anode, one becomes a cathode. This is called the galvanic process. So it's kind of the curse in the marine world. You've got these two great materials that are corrosion resistant. They don't rust in salt water, but you mix them together and they eat each other away. So in this case, we've got a stainless steel tank. These two tanks are going to weigh 500 pounds. We're going to bolt them in with stainless bolts because we don't want the bolts to rust, but we also don't want any galvanic corrosion to happen between the bolts and the aluminum. So I've created these little Delrin insulators. So what is Delrin? Delrin is a plastic. It's a extremely tough material. It's got similar properties to metal. It actually is commonly used as a bushing material, as a replacement to metal. It's also corrosion resistant. It's resistant to chemicals, fuel, UV, and it machines really easily. This is a great product to use as an insulator for our stainless steel bolts. Okay guys, tanks are done. That's it. These are the tanks for the 28-foot Pursuit. If you like these tanks and you want to find out a little bit more, I've got these on the website, so adventuremarine.ca, links in the description. You can find these tanks. You can also find all the connections that we used in this build. You can buy those if you need them for your own tank build. Obviously, leave comments, like, subscribe. It's just me, so I really enjoy getting your feedback of what you liked, what you didn't like. If there's something you want to see in the future, let me know. We want to do more of these tank builds as well as some other up-and-coming projects that we've got. Thanks so much for watching, and I'll see you on the water.